Hey.
Good morning, everyone. Please let me remind you to silence your microphone for the presentations to begin. Salome, the floor is yours.
Thank you, Adrian. Welcome to all of you. Thank you very much for attending this workshop and helping us to give more visibility our project, O4V. I am Salome Robert. I'm project manager at NATAC, and I'm the coordinator of the project. I would like to remind you that the workshop will be recorded. If some of the speakers have any issues with that, they can write in the chat. And so after having the more academic session of this workshop, we are going to see more real applications or closer application to the market and the sector more immediate to the value chain of our project. For this, we will have a presentation on the opportunities of biomass valorization, the challenge of biomass valorization, and we will have we can see the results of another sister project, Hem4Value. So we can start with my colleague, Alba. She's a PhD in biotechnology. She's a project manager in NATAC, and she will explain something about the biomass valorization and the opportunities for the market.
Thank you, Salome. Good morning, everyone. I will start sharing my screen. Okay. Can you see it now?
Yes.
Yes.
Great. So, good morning, everyone. I'm Alba Ramos, project manager at NATAC, and I will start with a short presentation about what we do in NATAC and then some examples about biomass valorization, specifically focused on the olive. So, NATAC is a business group dedicated to research, developing, and manufacturing natural ingredients, mainly botanical extracts, with a special focus on Mediterranean plants. So basically, what we do is to extract and purify the active compounds from different botanical matrices, and we apply this final product from different market sectors, mainly nutraceutical, food, animal nutrition, pharma, and cosmetics. We are located in Spain. We have the headquarters in Madrid. We have also an olive factory in Cordoba, and we have recently opened a multi-product production plant in Hervás at the north of Extremadura, when we have centralized most of our production. We have also some sales commercial office, one in the United States and other one recently opened in Singapore. NATAC has developed a totally innovative business model based on a sustainable strategy. The origin of this strategy was the use of some residues or side stream from the agri-food industry that generate around 25 to 60% of unused biomass. So we saw this potential, and we decided to start with the valorization of this non-valorized and non-used biomass. So we are wasting natural resources that also contribute to environmental impact and nutritional and functional waste. So we will be solving two different problems with this one approach. NATAC begins with the evaluation and understanding of the whole supply chain, specifically in the agricultural and industrial processes that use these botanical resources to understand what point of these production processes were critical and have this potential for valorization. We are committed to designing circular bioeconomy strategies for each plant, and we upcycle this byproduct as source of botanical extract, converting them into different value-added final ingredients that have a strong potential of people health. And this model finally leads to a more robust environment. So as I have been explained, we design an innovative business model based on the upcycling of a plant-based raw material. This sustainable business model ensures the full use of these botanical resources for converting them into value-added ingredients. The benefit of this model is, firstly, the specialization in Mediterranean and other strategic plants. This is one of the main focus of NATAC in Mediterranean extracts. Also, we have the complete control of the whole value chain from the market farmer to the final ingredients. Also, we provide a wide variety and a large quantity of final ingredient base of this raw material. We develop different products for different applications, this market sector that we have been seeing before. All our innovative ingredients have a strong scientific support. So why olive? Olive is one of the most important biomass for NATAC. It's a key industry in Spain, as you know, is a biomass that is located and available in one place and through the whole year. Also, the biomass management represents an environmental issue, so it's also one of the focus of this environmental strategy. Olive represents a Mediterranean diet flagship, very appreciated in the health market. So it's also a good starting point for us, and it's a biomass rich in bioactive compounds present in the market and with high potential for final valuable application. Here you can see the classic flow chart from the production of extra virgin olive oil and all the other side streams that are generated in this process. Here we saw good opportunity to develop different processes focused on each of these side streams to generate new biomass and with high potential for generate final high added value ingredients. So now, based on this classical flowchart, we develop different products based on each of these streams. So we design a new flowchart based on the biomass processing from each these streams, and we obtain different final products that we have already commercialized from different market sectors. And now we are going to see some examples from one of each of these streams. So firstly, we start with endolive and palm olive. These both products are designed by NATAC from the nutraceutical market. These samples of products developed, we will start with endolive, that is a product designed for natural cardiovascular protection. So it is a patented product. This product contains triterpenic acid, oleanolic acid, muscarinic acid. Also, it has hydroxyterexol, that is a high antioxidant potential product, and beta-sitosterol. We started by developing on some preclinical studies that saw very good results, and then we designed finally human viability study to actually assure that these bioactive compounds have a strong effect also in humans. And we developed a physical clinical trials in humans, finally having very, very good results in these trials. This product was, as I already told, designed for cardiovascular protection, and it has shown very positive results on blood pressure, serum glucose, cholesterol, and it has a general effect on lowered cardiovascular risk score. So all of these markers finally are pointed to a good and strong cardiovascular protection. It is developed by the olive fruit, exactly the pomace olive oil, and we commercialize it in different areas, mainly in Europe and the United States. Also, we have another examples that is Pomolive. Pomolive was specifically designed for metabolic syndrome, and it combines the potential of olive and apple. So we take triterpenic compounds from olives, specifically from olive leaves, and some derived polyphenols from the apple. So this combination results in an unique synergistic effect on glucose and lipid profile that are some of these critical parameters related with metabolic syndrome. Firstly, as before, we developed some preclinical studies in mice based on the positive results of the preclinical study. Finally, physical clinical trials were also included. All as before, here we commercialize these products in Europe and the United States. So these are two different examples of products developed from the pomace olive and the olive leaves as a side stream of this production of the extra virgin olive oil. Continuing with some examples, here we have aqua-olive, that is a product obtained as viability. This is derived from a problem that we saw in the intensified agriculture that has actually led to a big loss on farmers' productivity and profitability. So based on this product that we observed, we decided to develop an additive to be used as a feed, and this additive have different positive effects. Firstly, it reduced by a 9%. It increased the 9% of the production by reach the commercial size of the feed. So with the same amount of feed, we will increase the commercial size. So you actually need less feed to feed this in this fish in the aquaculture. So also not only the increase in the commercial side, but also the quality of the meat. We increased 8% in premium pieces. So we obtain high quality meat of this fish. And also at the same time, we reduced the use of medication, enhancing the health global status of the fish. We reduce the use of drugs, and also as a consequence, we reduce the environmental impact. So this combination finally produced a 15% of increase in farming global profitability. The mechanism of action behind these effects is the anti-inflammatory and antioxidant activity of this additive, as we call aqua-olive. Aqua-olive improves intestinal health and lipid metabolism, resulting in this positive effect in the gut barrier and leading to this global increase in the profitability and all the health of the fish. As a summary of this model we have been seeing, we go from a waste management model that not generate any higher added value potential in the industry to a model based on biomass processing. So this model is summarized by these two sentences from the image. So using better what we already use and using well what we don't use yet. So here we valorize each of these side streams of this model. We have been talking about a specific example of olive industry that is one of the key points of the model for NATAC, but we are also working in other biomasses. And this model is comprehensive. It's based on a sequential case process, obtaining multi-product model. So this model could be applied for different biomass and also obtaining a whole range of different products, starting from one specific raw material, obtaining maximum valorization and assuring sustainability. And finally, about bioeconomy and bioeconomy opportunities, the multi-state industry provides a dimension, competitiveness, differentiation, and specialization that is difficult to replicate by any of the traditional model of exploitation that have been used traditionally in the industry. And it's provide a unique and sustainable competitive advantage over time. So this is all from my side. Thank you very much. And if you have any question, I will be happy to answer. Thank you.
Thank you very much, Alba. I think it's very interesting to see more applications of the real opportunities in the market. However, it's also so important to know possible problems that may arise in order to know how to act in those cases. So for this, we have today in this workshop Margarita de Gregorio. She's a PhD in Natural Resources Economics and coordinator at Bioplat. Margarita participates also in the advisory board of O4V, and she's going to tell us a little bit about the different challenge of biomass valorization. So thanks, Margarita. You can start whenever you want.
Good morning. Thank you so much for inviting Bioplat to participate in this interesting workshop. I'm here to speak a little bit to give an overview about the challenges for the biomass valorization. And I'm going to start just... Sorry, I was in mute. Good morning. Thank you so much for inviting Bioplat to this interesting webinar. I'm going to speak a little bit about the challenges that exist for biomass valorization, but as well about some drivers and other benefits that are induced by this way to take advantage of these residual streams, subproducts, waste. And I'm going to start my presentation by introducing Bioplat. We are the Spanish platform in which we promote the valorization of any kind of organic matter to produce bioenergy, biofuels, and bioproducts, bio-based products for any use. We are a public-private group that was constituted in 2006, and we are working together to consolidate the sustainable use of biomass as a source of energy, fuels, and bio-based products, while promoting regional, national, and international cooperation in the field of bioeconomy. This is just an overview of my presentation. We are going to start speaking about some drivers that are here and are facilitating the valorization of biomass, the big challenges that we have to valorize this organic matter, this biomass, how research and innovation can enable the success of this sustainable business model, and some final remarks. And try to do everything in 10 minutes, okay? In case you have any comment or question, you will be able to ask after my presentation. Right now, there are several drivers that are allowing, that are somehow facilitating the valorization of biomass. The first driver can be the bioeconomy policy that is right now getting promoted in the European Union. We have the bioeconomy strategy and the bioeconomy action plan. Bioeconomy is on the political agenda. Almost 2 months ago, the Council of the European Union published this statement regarding the promotion of a more sustainable, competitive, and resilient Europe, and trying to boost rural areas. So the Council approved the conclusions of the opportunity of bioeconomy regarding rural and coastal regeneration, farming and forestry, and as well other kind of recommendations. So bioeconomy is a reality and is being boosted by the European Commission, the European Parliament, and the European Council. We have as well all the policies related to circular economy, the Circular Economy Action Plan, the new Circular Economy Action Plan, the first package of measures to speed up the transition towards a circular economy that was launched in March 2022. And as well in November 22, the Commission proposed a new European-wide rules on packaging and is growing all the interest and policies and recommendations and regulations regarding circular economy in the European Union as well. In July 2021, the Fit for 55 package was published. This package aims to reduce by 55% the emissions by 2020. So it's a very, very ambitious package that tries to make changes in emissions trading system, social climate funds, the carbon border, member states emission reduction targets. So it implies the modification and update of 13 European regulations, 11 European directives, within them the Renewable Energies Directive. So it's a very ambitious package that is pushing as well the economy in the way to save emissions. The Repower Europe package that was published in May last year aims to rapidly reduce the dependence on Russian fossil fuels and as well fast forwards the green transition. This plan is taking into consideration some bio-based forms of energy and fuels, and is just driving this change to a new economy, and somehow to have more sovereignty as well in Europe and being less dependent of third countries. And the Renewable Energies Directive, the RED II, the RED III, that is being updating the agreement between the three parts was reached just right before Easter, and the RED IV that is as well being developed now is there is a big commitment to promote bioenergy, biofuels, and there are other facilitators that are as well ongoing, as the Biomethane Industrial Partnership, the European Net Zero Industry Act, and as well in the field of the R&D&I, the SET plan, the Horizon Europe CBE, the Clean Energy Transition Partnership, Mission Innovation, the Integrated Biorefineries Mission that is there. So all of these drivers are ongoing, are looking for different targets, but in the same direction. That is to be able to make an evolution to go through a ecological transition, saving energies, and as well being less dependent on fossil fuels, not only in the field of the energy and fuels, as well in the field of products. So we are, all of us, immersed in this change. And so this is very good for the biomass sector, for the bioeconomy sector, because it sets, the foundation that is going to allow this sector to be bigger and to be more integrated in industries, and the future is very clear and very challenging. And regarding the challenges of the valorization of biomass, As you know, there are a great variability of feedstocks that goes from agricultural, forest, livestock industries, landfill, that could be converted into biofuels, bioenergy, bioproducts by several and numerous immense way to valorize this biomass, So these valorization processes can be more or less complex, and it can have variable scales, so it can go from very small units of valorization to huge ones. And the main valorization processes are thermal, hydrothermal, thermochemical, biological, biochemical, and the mix of all of them. As you know, we have the main exponent of these valorization processes are biorefineries. NATAC is a great expert in biorefineries. So this can be very simple, very complex, very small, very big. And this is the greatness that we have when we work with biomass, when we work with the organic matter of products. And this valorization of biomass processes, of course, has huge, big challenges, but these challenges have been, the sector has a great knowledge to overcome these challenges, and we are going in that way. One of the main challenges of valorization of biomass is logistics. We are not solar, we are not wind, we are not water, we are biomass. We have to take that biomass from the agri, from the forest, from the blue, from the fisheries, from the sea, from any kind of food industry, from landfills as well. So there are many different sources of biomass, and the challenge is getting that biomass from those sources in a very efficient, competitive, and sustainable way. There are some real, let me call them artists in industries, and they are really good in getting this biomass, in developing those logistics, efficient logistics to get that biomass. But it's in fact a challenge, because when any industry from outside our sector is interested in the valorization of biomass, the first, let's say, barrier that they find is the logistic. How can I get this organic matter from my biomass, even though are my waste of short products? No? So this is a great challenge. And there are, of course, many ways to make this easier, but it's a challenge, and it's something that is going to be there always, because we are working with something that is tangible. It's not coming spontaneously to the valorization installation. So logistics is a key. But if you control logistics, you really control the business model. Another challenge that we are fighting against it is knowledge. There is a lot of knowledge in our sector, and having this knowledge, having this information regarding our sector is basic for decision making at all levels. Users, industries, and end users that probably could be interested in using our biomass, but as well for policy and support. So all decision makers are making important decisions regarding our sector. So it's very important they know about our sector. They know about the potential that our sectors have, and as well the potential benefits that our sector induce, as well the challenges that our sector has, and as well the ways to promote bioeconomy, generation of jobs, valorization and reduction of waste, emissions. So those immense positive effects, and less as well some backwards that we have in our sector, must known, by these potential users and by these decision makers. And this is a great challenge that we are working as well a lot to overcome. Another challenge is the policy ambition at a national, regional scale. And this is fundamental to create a favorable conditions to deploy the sector and the market. So we should be more ambitious at all levels. We should really promote this as one of the first environmental policies, one of the first of energy policies, one of the first of socioeconomic policies to fight against the just transition challenge, and as well everything related to fair transition in general. So this is another challenge that we have to combat, and we have to try to work. We should be more ambitious. Sorry, in general. There are some other specific technical issues. There is still a long way to research, to develop, and to innovate, to increase the competitiveness, and being able to provide even more sustainable solutions. So if you see our technologies in our sector, we have some very mature valorization technologies, but there are other valorization technologies that are in TRL 5 to 8, and they should be developed, to provide even more competitive solutions. And this is a challenge as well, but this is a great challenge. So having the chance and being in the moment in which we have in our hands the possibilities to evolution these technologies, I think is great, and we are very lucky. So this is a very great challenge. And we have another challenge that is related to the market uptake of our energies, fuels, and bio-based products. So this is a great challenge. We need to really guarantee the utilization and commercialization of the valorized output from our valorization technologies. So we are working hard as well to beat this market uptake challenge, but these 5 are, from our point of view, the greatest challenges to promote the valorization of biomass. The sector is working hard to try to overcome these challenges, but I mean, we are right now launching many new technologies and products. So I think these challenges are natural, is normal. We have these challenges in the state that we are in the sector. Next to these challenges, we have some benefits, because we promote economic value in territories, and this is very important. We promote social value in territories. We invest in territories. We are able to promote these sustainable investments, these sustainable technologies, industries in the territories, and this is very important, because this promote, the jobs linked to that very sustainable business model. So this is very important. We as well induce a very important environmental value, because most of the organic matter that we valorize comes from waste, comes from residues, and that waste and those residues generate emissions and generate pollution and generate many other negative effects that we are able to neutralize, and we are able to convert in good products, in good energy, in good fuel. So those challenges are linked to this added value that is very important for society and for environment in general. Research and innovation is key for success. This Olea for Value product is great to untap, this potential of the valorization of this biomass from the olive oil industry. We are as well involved in a project from Bioplat that is called IRODI. In this project, we use as well all the the lateral streams of the production of olive oil and other vegetable oils to produce some bio-based products to be used in the cosmetic industry, in the food industry, and in the adhesive lubricants and industrial industries. So this is very important. How are we becoming more and more able to stream these residual streams to generate new bio-based products and substitute some fossil fuels derived in this cosmetics, in this food industry, and in this adhesive lubricants industry. So we are doing that. Olea for Value, IRODI. So please trust in R&D projects, get involved in this R&D and I projects, because it's very important to provide solutions for these industries and to keep moving to a bioeconomy world. More information of this project you will be able to find in the website. We have some very interesting videos as well. We invite you to take a look. And just some final remarks. In Europe, we have a very strategic position to deploy the biomass and the bioeconomy sector. We have a huge amount of existing organic resources, feedstock, and we have the ability to develop new species as well that could be used in the sector. We have as well a strong private sector that is interested to invest. We have as well a favorable political context. We have some interesting drivers that can be take in advance, to develop this new way to produce energy, fuels, and products. We need to create jobs. We need to fight against climate change as well. And we need to create local industry that implies an increase in wealth, revitalization of the rural environment, because we have to fight against the demographic challenge. So all of these come together within the concept of biomass, bioeconomy, circularity. So let's go together. There are, of course, so many challenges, but there are great benefits. So let's go together and continue working in this field. Thank you very much.
Thank you very much, Margarita. This was really interesting and really useful on this information. And we have today Concepción Muñoz. She's a professor in the Department of Agronomical Science in University of Córdoba. She's also participated as coordinator in a project sister of Olive for Value, Gen for Olive. So Concepción is going to tell us a little bit about the results of Gen for Value.
Good morning, I am Christopher. I am
okay.
Here. I'm going to present the Gen for Olive project. Concepción wasn't able to, but don't worry. We was going to be together, but she had to be in class, so she couldn't. So I'm going to share my screen. One moment.
Thank you.
Okay, can you see it?
Yes, we can see it.
Okay. Okay, first of all, thank you for inviting us. I'm sorry that my camera is not working today, but I'm trying to do the best. Basically, okay, my name is Christopher Mijo. A lot of people knows me with Freddy also. I am the project manager of this Gen for Olive project, and Concepción Muñoz is the project coordinator. We are coordinating this project from Córdoba University, so I'm trying to summarize it in 10 minutes. Basically, Gen for Olive project is dedicated to the pre-breeding activities of the olive crop. Just to have a little view of the olives, we have about 11 million hectares of olive orchards in the world in 67 countries. And let's say we have different genetic resources, cultivated ones and wild olives. So we count that in the world there are about 1,200 cultivars. or different genotypes that we doesn't know very well them characteristics yet. So we are trying to analyze these genetic resources in a lot of aspects that we will see in the other slides, and then try to accelerate the breeding programs. It means to have new olive genotypes with better characteristics than the ones that already exist. So there are different risks regarding to the olive crop and other crops, such as genetic erosion. We are passing from a traditional system of the olive farming to super high density systems. In these new systems, there are few genotypes, little genotypes that can be adapted. So we are losing a lot of genotypes during this process. We have about 5 to 6 cultivars that are being planted in all the world. On the other hand, we have climate change problems and other different projects that may cause different problems in the future of the olive crop. Also, for example, the pests and diseases such as verticillum, xylella may be higher risk for the future. So basically, to somehow resolve these problems, we are conserving the olive genotypes in a bank collection, germplasm banks. So we have about 69 collections in all the world. We have about 4,200 accessions, which mean different genotypes in all these collections. And the problem here are the correct identification of these crops and then the good or high classification of them. After these two processes, let's say 2 steps, identification and characterization, we can go forward with the breeding process to obtain new cultivars. Okay, so to resolve these problems, born the Gene for Olive project, which is a European project, Horizon 2020 project. It started in October 2020 and it will finish in October 24. Here participate 16 different entities, partners. Here are the logos of each one from 7 different countries. And in this project participate public entities and private entities. Okay, so in general terms, we are trying, as I say, to characterize the about 500 genotypes found in the five germplasm banks that participate in this project under the same protocols. Firstly, we defined the same protocols in order to avoid errors in the evaluations between different countries. The main characterization that are carried out are the resilience to climate change, resilience to pests and diseases, production and quality, olive oil and olive table production quality, and adaptation of the cultivars to the modern planting systems. Then we are trying to, under the same protocols, to make the preservation or the correct conservation of these genotypes to the germplasm banks, and then pave the way for breeding or trying to develop new genotypes to have better characteristics in all these parameters. Okay, here is more or less the work packages of this project. And as I explained, we are going to evaluate these characteristics that I mentioned. Also, we are trying to understand the interaction between the genotypes and the environment effect. And then all this information we are going to store in a public database, in a web page that already is being constructed by Sapienza University in Rome. Also, we are trying to develop 2 mobile application able to identify the genotypes through endocarps pictures, images, and also detect pests and diseases also through images, so through pictures. So in general term, we are expecting from this project, and already we have obtained results related to okay, first of all, the correct conservation of the genotypes in the germplasm banks, and then evaluation about the pest and diseases, climate change, quality, and other characteristics. For this issue, in order to involve also the private sector, we implemented 2 open calls for the public companies, for the private companies, which participated with different private projects and are already being performed by the private companies. Okay, to see some tangible results of the Gym for Olive project, I selected for today the results related to the effect of the climate or the environment in the oil quality, in this specifically in the fatty acid composition. So we can see in this slide the differences of the water stress between the germplasm banks that participate in the project. So we can see here Spain and Morocco, which are, let's say, the yellow color, which means that it has been a lot of water stress, while in Greece and Italy, it was less water stress during the months that we were evaluating the olive cultivars regarding the oil quality. Okay, so we performed, for example, the flowering evaluation, and we found 2 clear groups, the Morocco, Greece, and Spain, which we call like Group A, and Turkey and Italy, Group B. And we found that in the Group B of the countries, the cultivars had a delay in the flowering by 30 days approximately. So we also found that there was a difference in the temperature, in the mean temperature between these 2 groups or 2 groups of countries by about 2.8 degrees. So this is a preliminary result, and we are trying to understand it better. But as preliminary results, we could say that in difference, where is the difference about 3 degrees Celsius, we have a 30 days delay in the flowering. Also, we analyzed the fatty acid composition of the olive oil in these 4 countries, analyzing the same cultivars, Arbequina, Lechino, and Frantoio of olive cultivars. And we found that, for example, there were significant differences regarding to the monounsaturated fatty acid or oleic acid between Spain and Italy. As we saw before, in Spain, we had higher temperature and more water stress than Italy. So we can detect that there are about 6% differences in the monounsaturated fatty acids, which are the healthy ones, between these 2 countries. And we could conclude, as also preliminary results, that the water stress or the high temperature may negatively affect the oleic content in the olive oil, which is the main fatty acids of the olive oil. Okay, I am not entering into many details, but here we can see the differences in the climate differences between the countries that participated in these tests or this analysis. And we can see that Spain, which is Cordoba collection, and Marrakesh or Morocco collection has much higher temperature than Greece and Italy, which are the red and blue lines. So it correlates with the fatty acid composition or oleic acid composition. This result suggests that by having higher temperatures, we will get less oleic acid content in the olive oil. Okay, the trend was the same for all the cultivars. So we can say that this is the impact of the climate change is similar to all the cultivars. In this case, for all the fatty acids analyzed during this process. On the other hand, we also found that the environment has, let's say, an impact in the profile of the fatty acids, but this impact is not too high comparing with the cultivar or the genotype factor. So we found that about 70% of the variance of the, for example, polyunsaturated fatty acid was explained by the genotype factor, and about 20% was explained by the environment factor. Then another preliminary results regarding the phenolic compounds in the olive oil that I wanted to present today, because also this webinar is more related to the, let's say, phenols and healthy compounds found in the olive oil or in the olive crop, let's say, olive fruits, etc. So we analyzed about 1,200 olive oil samples that were collected in the 5 germplasm banks, and we found a very high variability between the olive oils, in this case, phenolic profile. So we can see that we found, for example, varieties that had almost 0 ppms or milligram per kilogram of oleocanthal, and the other cultivars that are few of them, you can see here the points, that had more than 500 ppms of the oleocanthal. For example, that is a very healthy molecule due to the literature. The same happens for the other compounds. In the olive oil, we found that the aglycone forms and the methylated forms like oleuropein aglycone, lignostriaglycone, oleacein, and oleocanthal were the main phenolic compounds found on it. Okay, these are the main results that we wanted to present today in a few minutes. Thanks a lot. If you have any questions, I am open for it.
Thank you so much, Christopher, for sharing with us Gen for Olive results. It's very important giving more knowledge to the primary sector and to the environment. So congratulations for such an interesting project and results. And now I leave you with Andrea Leon. She's in charge of dissemination and communication activities in Olive Oil Value. Hi, Andrea.
Hello, I'm here.
We can see your screen, but not you.
Yes. But
Okay.
first of all, there is a question that I just saw in the chat that I believe it's for Margarita. I don't know if you can take a look and see. It's about your presentation.
Okay. Good morning, Sarah Eldem. Yes, seasonal production and supply is one of the challenges that is within the logistic challenge. So most of our agri-biomasses and as well food industry biomasses are seasonal. This shouldn't be a problem. We can in Spain, we've been working some years in an idea that is using the cooperatives, the agri cooperatives that are in the territories already established for being used as logistic centers, and that could help to let's say, modular somehow the seasonability of some biomasses. So if you use cooperatives or any industry that is established in the territory as a logistic center, you are going to have biomass produced by that cooperative in the months that that cooperative produced those biomass. But if you keep that space, that location as a logistic center, other production of other biomasses could be bring there to that logistic center. That means that you are going to have, let's say, a hub established in the territory in which some biomasses where they are produced in the season they are produced, they would be able to bring to that logistic center. Another way to fight against the seasonability of some biomasses is biomass dedicated crops. If you have biomass dedicated crops that they are not alimentary crops, they are not food crops, they are not feed crops, they are anything to do with alimentation. But if you produce those biomass dedicated crops, though that are some biomass species that have been developed for that purposes, and you grow them in some marginal areas, in some unused areas, that entry of biomass can be used as a complement for those seasonal biomasses. So, of course, the seasonality of biomass is a challenge, but there are some ways to cope with it using other seasonal biomasses in the seasons where you are not going to have your biomass, and as well valorizing some biomass dedicated crops.
Perfect. So now I'm gonna share my screen for the interactive questions that we have. Okay, perfect. Are you able to see my screen?
Yes.
Great. Okay, so you can now scan the code to participate. Okay, perfect. So we're gonna move to the first question. This one is related to Alba Ramos' presentation in NATAC. And the question says, do you think that this strategy model, the one presented by NATAC, for biomass processing could be also applied to other agroindustrial biomasses? Yes, it can be applied to other biomass. Yes, but only to certain biomass types. Or no, it is specific for olive leaves only. Okay, Alba, if you want, you could explain a little bit more the correct answer and the reasons why.
Okay, so yeah, I think most of you have answered the correct answer. Yeah, it can be applied to other biomass, but not all different biomasses, but some specific types. We from NATAC have developed this, we started to develop this model from the specific case of olive, but now we are working in expanding the model to the different kind of agro-industrial biomass. Here you need to explore the potential of all the side stream obtained from the biomass, and also to know and to go in deep to know how to integrate this complete cascading process starting from one specific raw material. So yeah, you need to evaluate, you need to go in deep, and then you need to adapt also your specific production process and your model, your business model, to this a new raw material, if you want to expand the model, and if you want to include new raw material for potential applications in your market sectors.
Perfect. Thank you very much for your specifications about the answers. Now we have the other question, which is related to Margarita's presentation, Bioplats. And it says, what is the effect of high temperatures on the nutritional quality of olive oil? And the answers are positive, negative, no effect is observed. Okay, well, Margarita, if you would like to explain the correct answer, which is, well, most of the audience has already selected a high voted answer.
I
so
think this
if you would like to
should be
explain.
for another speaker, probably. Yeah, I guess it's negative because it was explained. Yes. So yes,
Oh, this was actually for Gem for Olive's presentation.
exactly.
So if Christopher, you can explain a little bit the correct answer.
Yeah, the correct answer due to our result is that it looks to be negative because the oleic acid decrease with the increasement of the temperatures in general, the weather, let's say, the dry conditions. So we know that the oleic acid is the one that we want to have in a higher concentration in the olive oil, let's say. So this affects, I mean, the climate change or the increasement of the temperatures and the drought conditions looks to negatively impact the concentration of the oleic acids in the olive oil. So for this, we can say that in this sense or this aspect, the high temperature may negatively affect the olive oil quality.
Perfect. So that is it for the interactive questions. Great. So does anybody else have any other questions? The floor is open for general questions that you may have for the speakers. Yes. Somebody raised their hand. I think it was Paloma. Okay, well, if nobody has questions or any doubts, and we will then close this session for today. If you then think about questions and you would like to email us, feel free to do so, and the speakers will be happy to reply to your specific questions in case you have any. But yes, we're so thankful to have all of you in today's session and for listening to such experts in the field. And yeah, thank you very much for joining, and we'll be happy to see you in another session of Value for Value workshops. Thank you very much.
Thank you.
Thank you.
Thank you.
Bye.
Nice day.
Bye.
Bye.